As you know, Professor, I'm a journalist, and I've made an observation that we're on an island here. So I think it's appropriate to talk about the ocean in particular. And from the point of view of coastal areas, I gather the ocean is a bit of an area of particular expertise for you. From the point of view of coastal areas, what does the medium-term trajectory of global temperature look like? Whether we kind of want to call that 1.5 degrees, or you can tell us. But how should coastal communities be thinking about this stuff?
Well, the thing about climate change is that the ocean has been an immense asset for us up to now, because the ocean has absorbed a very large fraction of the extra heat that's been added to the planet. So water has a far higher specific heat capacity than air does, and the ocean has absorbed something like 93% of the added heat energy to the planet since the onset of the Industrial Revolution. Now, it's hard to really kind of put your head around how much energy is that, and the answer is an enormous amount. In fact, in 2023, the extra energy that was added to the ocean is equivalent to the amount that you would need to boil 5,750 cubic kilometers of water. So, if you're thinking about global warming, it's a very abstract thing, a tiny fraction of a degree a year or even less in the ocean, but in aggregate, that heat energy that's being added to the planet yearly is immense.
But it's also framed as a risk. With Hurricane Milton, we heard a lot about the higher average temperature of the Gulf of Mexico, and how that was a major contributor to the force of that hurricane, which happily weakened at the crucial moment. But are we reaching the limits of the energy that the ocean can safely and reliably absorb, as it were?
Well, I think that's a good question, safely and reliably absorb. The ocean will continue to absorb heat because it's got that capacity to it, but that is not going to be safe for us. And one of the areas in which that lack of safety in the sort of medium to long term is very evident is in sea level rise. And so, sitting out here in the middle of the ocean, at least Bermuda has a bit of vertical relief. Other countries are not so lucky. So the Maldives, for instance, has 2 meters of vertical relief between the seashore and the highest point on most atolls. And with sea level rise accelerating, as it is, and predictions of sea level rise going up.
Just scale that for us.
Okay.
In time and level.
Yeah. So since about 1880, sea levels have risen by about sort of 25, 30 centimeters, which is quite a chunk, but it's going to get much worse because sea level rise predicted to the end of the 21st century could be as much as a meter, but it's not going to stop there. And that's the thing about the climate system, is that the warming that we've already built into the system, which will play out over thousands of years, is going to drive sea levels up by much more. And so the modeling that the Intergovernmental Panel on Climate Change has done suggests that we're going to exceed 2 meters of rise under a business as usual scenario by 2150, and under a much lower emissions scenario, best case scenario, by sort of maybe 2300. But it's almost
at 2150 after 2 meters, how much land have we lost?
Quite a bit, most of Miami, and a whole chunk of Florida is very, very low lying. It consists of fossil coral reef, and in terms of risks, you can't build a seawall.
I never liked Florida that much anymore.
You can't build a seawall on an area of porous ground and expect to keep the sea out, because it just comes up through the ground. So, there are certain areas that are essentially abandonment is the only option that we have.
I want to talk about a couple of things, but one of them is remediation. You talked about the failure of building a wall, but and insurers will, of course, be thinking about this. If we want to limit the damage from rising sea levels, what are the rational courses of action available to us?
Well, there are a lot of hard engineering solutions to that kind of thing. In some places, seawalls will work, but they're very expensive to
They have worked in Amsterdam a long time.
They have indeed. And in other places, kind of more nature-focused solutions will be beneficial. And so adaptation involves, for example, replanting mangrove forests that will help keep pace with sea level rise, and that brings a dual advantage of also drawing down carbon dioxide from the atmosphere. So I think the name of the game here is to try and reduce emissions as fast as possible, but also to increase the amount of uptake of carbon by nature, and the ocean can play a big role in that, I think.
What are your, I'll get to a less depressing question shortly, but what are your big worries about the ocean over the next 50, 100 years? You talked about something which I didn't know about, which is Atlantic overturning circulation.
Well, until now, this has been sort of a low one on the worries of the world community. But the Atlantic meridional overturning circulation is the sort of northern arm of the global ocean conveyor belt, which is a surface and deep sea current that turns over on the order of 1,500 years, and it loops around the planet. And the North Atlantic arm of that.
So one lap is 1,000 years.
Yes, that's right.
Okay.
Yeah.
Right.
So the North Atlantic arm of that is kind of driven by the wind-driven Gulf Stream, which separates out into the North Atlantic Drift, and then it sinks. The water gets really cold and it sinks, and then that forms the pull, which is from the deep ocean. And so it's this push and pull that keeps the current going. But unfortunately, ice cores tell us that it's stopped in the past. And it stops on a fairly short time scale, decades to a century or so. And one of the worrying things that we're seeing is a slowing down in that Atlantic meridional overturning.
And will that be a warming event? Will that accelerate warming?
Well, the only place on the planet, if you look at the temperature history of the planet in recent decades, the only place in the planet that has cooled relatively is off southern Greenland, and that's because there's less heat coming from the tropics in this Gulf Stream-driven heat pump.
Ah, very interesting. So that trend might change.
That could change.
Yes.
I mean, this was popularized in the Day After Tomorrow movie. It won't change that fast, but it's a risk, and it's now a risk that people are talking about as a significant one.
I want to turn the focus to the particular interests of the people in this room. The insurance industry prices usually on an annual basis, and they look at the evolution of risks in previous years, and they apply a model, maybe an AI model now, to project for 1 year. Are there areas where what is the insurance industry possibly missing in terms of the evolution of climate change and how that's going to change the risks that they insure?
Well, I think it's been changing the risks for some time, and as one of the speakers said today, you're all sitting on a huge amount of data, and that data embeds, the kind of changes that have been driven by climate change already. And so looking forward, there is an acceleration likely in some of those risks. Inundation of low-lying areas is likely to get more rapid. The extremes always rise faster than the averages, which is awkward because that's the bit
the extremes that matter.
The worrying piece for insurers, yes. So I think the big problem, though, is the non-linearities, the tipping point issues.
Yes.
And we're not very good at predicting those, and nor is AI at the moment. We've got ideas of where some of those tipping points might lie. Ice sheet instability, for example, driving very rapid sea level rise. That's now being considered seriously by the Intergovernmental Panel on Climate Change, but they can't say much about the absolute risk. It may or it may not, and it's hard to go beyond that.
As always, the good professor is happy to answer your questions. Would anyone like to put up a hand in the audience? Or maybe this is paralyzingly depressing, but we'll charge on here. We haven't, but if you do, anybody can stick up their hand at any moment, and we can get into your questions. We haven't talked, it was interesting that the most dramatic events in the United States involving water this year were not near the coast. I'm thinking of things like the floods in North Carolina. So if we turn the focus from sea level rise to a broader picture that includes things like rainfall or, I suppose, drought, how does the picture change or stay the same?
Well, I think one of the interesting things that, any reasonable chance of achieving the 1.5 degrees of warming of the Paris Agreement, and not many scientists now believe that is possible, and the PwC net zero economy tracker suggests that we need to be going 20 times faster in terms of decarbonization to get to keep within the 1.5 degrees centigrade of warming. But any chance of getting to those lower figures is dependent on, one, weaning ourselves off fossil fuels, and two, increasing the ability of nature to absorb carbon. And so that's where there is a gleam of hope, I think.
Yeah.
In the ocean, we're very interested in how the oceans absorb carbon and store carbon for the long term. And the world is busy looking for high integrity carbon credits. That whole market of carbon credits has been somewhat discredited because of things like double accounting, and saying that these forests would be lost when they're not really at risk at one time. And so you're simply avoiding the painful reductions in carbon that need to be made. But I'm lucky enough to run a project which is called the Convex Seascape Survey and is supported by Convex. And we're interested in looking at how the seabed stores carbon and where that carbon is stored and what we're doing to it and whether what we're doing to it puts it at risk. And long answer short, yes. Whenever you disturb the seabed, then you put that carbon at risk
Re-emerging into the atmosphere.
Re-emerging into the atmosphere. And so, one thing that you could do to develop a high integrity carbon credit is to stop disturbing the seabed and fish using means other than dragging nets across the seabed, which does disturb a great deal of sediment and carbon and causes a risk of loss to that carbon over time. So there is a way we can build up that carbon sink again and see an increase in it. And there are a lot of people who are interested, if the numbers work out, in monetizing that as a means of investing in a nature-positive solution, which is going to, bring back a lot of biodiversity that's been lost from these areas. It's not going to reduce fish catches because you can catch fish using other methods.
Yes.
But it is going to protect carbon, and it's going to help recharge the ocean's ability to absorb carbon.
So help me sum up, as it were, your outlook and how it might be relevant to people who are interested in pricing risk. We know that we have an the problems that we're seeing now are on an accelerating path, and that path is itself quite uncertain. Is that how you would summarize? And you have to price for more and greater levels of volatility. Is that how you would summarize the situation?
I would, yes. I think, one of the depressing things, I don't like to end on a depressing point, but one of the depressing things is that net zero isn't working. If you look at it, we're simply not seeing any inflection in the curve of carbon dioxide concentrations in the atmosphere. In fact, we're seeing inflection going the wrong way. It's accelerating. So, whatever we're doing now, it isn't enough to draw down the driver of climate change.
So we have to think hard about remediation.
So remediation is important, but people have talked about it in here earlier today, and that is you can't build back in the same places because you're just sort of magnifying the risk over time. There are areas that are going to be utterly uninhabitable and uninsurable before long because they are simply going to be reclaimed by the sea.
And of course, part of the value of insurance is it sends risk signals about which places those are. And then we have politicians to cancel those signals, so that's all very positive. It's been a real pleasure talking to you, Professor. I hope you'll join me in thanking Professor Roberts.
Thank you.